Good morning, ma'am. This is Kena Samarati from third year CSC C section. Today I will presenting the actor and critic methods and active reinforcement learning. The introduction of the reinforcement learning. Reinforcement learning or ARL is a core of area machine learning where an agent learns to make optimal decisions through interactions with within its environment. The key object is minimize cumulative rewards over time. In simple terms, imagine training a robot dog. You can reward it. You can give a reward when it does something good, like sitting when we told, or no rewards when it doesn't do. Over time, it learns when actions bringing rewards and repeat more efficient. In traditional reinforcement learning methods, there are two main types: value-based methods and policy-based methods. Such as value-based methods, such as a cue learning, where the agent learns how value certain actions are given in the states. In a policy-based methods, such as reinforce, where a agent directly learns a mapping from states to actions. But both these having drawbacks. Value-based methods are struggle in continuous action spaces, while policy-based methods can have high variance. High variance. The concepts of the actor-critics method. The actor-critics framework is a hybrid approach that uses two components, actor and critics. Actor where decides when what actions to be taken based on policies. Critics evaluate how good that actions was be estimated the values. The critics acts like a teacher that provides constructive feedback to actor, helping it improve his decision over time. For example, in a self-driving car, the actor chooses an accelerator or brake, while the critics evaluate the resulting safety, speed, and control. The critics' feedback helps the actor refine the driving policy to balance safety and efficiency. The actor represents the policy functions which maps state to actions. The policies is usually denoted as phi, phi of A, comma, S of theta, where theta represents the parameters of the functions, like weights in a neural networks. The actor updates its policy parameters in a direction suggested by the critic. The main goal of the actor is to find policies to minimize the accepted cumulative. The critic. The critic represents the value functions which measures the quality of a given state or action. It typically denotes as a V of S, W or Q of S bar A bar W, where W represents the parameters of the critic. The critic evaluates how good the actor's actions are evaluated, calculates the temporal differences error. The TD error is computed as a delta is equals to R plus gamma V of S bar W minus V of S W. The TD error serves as a feedback signals to both the actor and critics during learning. Working mechanism. There are different steps of working mechanisms. There are the actor observes the environment current state, and the next step is it chooses an action based on its policies. The environment returns a reward and a new state. The critic compares this reward what it expected. The differences is called temporal differences error. The critic updates its value estimating and the actors adjust its policies to favor actions that reduces the error in futures. This continuous feedback loop makes the learning both faster and more stability. The example in a robotic arms controller system, the actor decides how far to move the arms, while the critics monitor how close the motions was to be reserved positions. Over many iterations, the actor learns the both moves and move the arm with a high precision and fluid motions. The mathematical formulations of the actor and critics are the actor parameters theta are updated as follows. Theta t plus 1 is equal to theta t plus alpha t delta t delta in pi of at comma st delta t pi t. The critics parameters for w are updated as wt plus 1 is equal to wt plus alpha w delta t v of st wt, where alpha theta and alpha w are learning rates and delta t is a temporal differences error, where represents the gradient operator. The advantages of actor critics methods are faster convergence, combines the stability of value based methods within the flexibility of policy based methods. Continuous action handlings can operate efficient in environment with continuous action spaces, reduces variance. The critic reduces the variance of gradient estimate from the actors. Stability learning. The critic provides smoother learning signals for policy updates. The disadvantages of actor critics methods are training two networks simultaneously increases complexity. Tuning learning rates and parameters can be tricky. A weak trained critics can be misguide the actor's learning to instability. Here the applications of the actor critics. These are the methods are widely used in robotics, gaming AI, autonomous driving, financials, and healthcare. In the robotics, controlling arms and drones for humanoid robots. In gaming AI, famous examples like including AlphaGo, which use policies and values network for strategy decisions. In the autonomous drivings, for optimal steering and braking policies. In the financial managing portfolios via continuous policies adjustments. In the healthcare adopting treatment plans for individual patients. In the active reinforcement learning, while traditional reinforcement learning learns passively from every experience, not all the data is equally useful in the real-world settings. Data collections or human feedbacks can be costly. That's where active reinforcement learning or active RL comes in. In the active reinforcement learning, the agent does not just learn from all the interactions. It strategically decisions when and what to query. This makes learning more efficient, faster, and cost effective. Think of training a medical diagnosis system instead of asking a doctor to label every case. The AI select to query the doctor only when it ensures about the about the diagnosis. Over time, it learns to make accurate predictions while minimizing cost experts. Active reinforcement learning thus blends idea from active learning and RL, focusing learning effects only where the information is mostly valuable. The working principles are the process of involving the following steps: observing, decision, action, selection, query steps, learning updates. In the observation, the agent observes in a state in the environment. In the decision, it decides whether the query that teachers are rely on its experience. In action selections, it confident it acts based on its current policies. In query steps, it uncertainty the if ask from feedback from external sources. Learning updates. It updates its policies using received feedbacks. For example, a self-driving car might only ask for human interactions when it encounters a rare road scenario like unexpected construction zone, thus learning efficiently. There are different types of active reinforcement learning. These are the two mainly types: exploration based active reinforcement learning and query efficient active reinforcement learning. Prioritize uncertain states or actions to maximize knowledge for exploitation based active reinforcement learning. The example of active reinforcement exploration based active reinforcement learning is educational tutorial systems selects questions for students based on topics they are less confident about. In query efficient learning, active reinforcement learning limits the number of feedback requests only asked when uncertainty is high. For example, a customer supports chatbot queries a supervisor only for ambiguous customers queries, saving time and cost. Here the advantages: learning efficient with fewer interactions, reduces overall training cost, focus on the most information data, ideal for human in the loop systems. The limitations of the active reinforcement learning is hard to compute uncertainty accuracy, increases computational demand for queries, balancing queries and cost, speed remains challenging. Here the real world applications of the active reinforcement learning is human in the loop systems, teaching robots or AI assistant efficiently, autonomous vehicles asking for human controller only when uncertainty is occurs, recommended systems asking user about preferences to improve personalization in the healthcare, minimizing unnecessary patient interactions while improving care plans. And the conclusion is actor-critic method brings stability and efficient to reinforcement learning through policies and value science. And the active reinforcement learning takes its future by making learning data efficient and cost efficient through they represents the next towards intelligence adaptive systems. Thank you.